Everyone has been to a mechanic before. Likely, you took your car to him or her either for regular maintenance or because something went wrong. Because of their understanding of those fickle, ubiquitous machines we all use, they were probably able to diagnose the problem relatively quickly and get you back on the road in a few days at most. Far fewer people have ever been to a biomechanic, or even know what one is. In this lesson, we will explore what exactly the field of biomechanics is and look at its applications and uses in the 21st century. Biomechanics is the study of how the systems and structures of biological organisms, from the smallest plants to the largest animals, react to various forces and external stimuli. In humans, biomechanics often refers to the study of how the skeletal and musculature systems work under different conditions. In biomechanics more generally, scientists often try to apply physics and other mathematically based forms of analysis to discover the limits and capabilities of biological systems. In a way, biomechanics has been around since the inquiring ancient Greek and Roman minds began dissecting animals and vivisecting humans to discover the inner systems of our bodies. Many of the great philosophers and scientists of our past tried their hand at some form of biomechanics, from Aristotle, who wrote on the motion of animals in the 4th century BC, to Leonardo da Vinci, who studied human muscle and joint function in 15th century Italy. In the 19th century, scores of Europeans were incredibly fascinated, for some reason, with the gait of horses and extensively studied the biomechanics of a horse's galloping motion. Today, rather than a field that scientists and philosophers dabble in, biomechanics is its own branch of human and biological science, with entire departments in hospitals and universities devoted to the subject's study. Since biomechanics is the study of human movement and interaction with the environment, the field has myriad applications in daily life and touches on many different sciences. Let's look at a few examples of the areas in which biomechanics is most commonly used. Biomechanics is certainly popular right now in sports and athletics. Sports teams and athletes themselves often hire entire teams to study the movements and forces inherent in the various regular motions and important actions during the playing of a sport. A good example of this is the swinging of a baseball bat or golf club. These are both motions that contort the human body in strange and irregular ways. Teams and/or individual athletes often hire scientists and therapists well versed in biomechanics to study an athlete's motion, often using slow-motion cameras to study the angles and forces that go into each action. At the highest levels, figuring out a way to squeeze that extra little bit of power out of a baseball player's swing can be the difference between a pop fly and a home run. The principles of biomechanics don't just matter for large organisms like humans. They're applicable on the smallest scale as well. Indeed, today's scientists are using biomechanics to study animal, plant, and human tissues and materials and discover their most basic properties. Some scientists apply stress and forces to different materials in order to understand which are strongest under which conditions and how we might be able to use that knowledge to help design new or better medical procedures. Others are examining the basic structures of biomaterials at the cellular and molecular level to find out what biology can teach us about creating stronger synthetic materials. Scientists that study comparative biomechanics try to learn from the motions, processes, and functions that plants and animals have already developed to overcome life's problems. This is particularly true in locomotion, where scientists in comparative biomechanics routinely study the flight of birds or the motions of fish and sea mammals to better understand how these animals are such effective flyers and swimmers. These scientists hope to apply what they learn to inspire the creation of new materials, processes, or entirely new inventions to aid human or machine motion. Comparative biomechanics is practiced in virtually every science, including medicine, where animal resistance to certain diseases is studied to try to find cures or remedies for humans. Biomechanics is the study of the structures and materials of human, plant, and animal life, and the effect of external stimuli upon those systems. The field is a cutting-edge science, but it has ancient roots. For millennia, humans have poked and prodded and tried to figure out how different organisms work. Today, biomechanical scientists are applying what they learn to an enormous range of areas, from sports to nanostructures to flight.